Hello everyone, my name is Manas Pathak and I welcome you all to today's video. Today we are quickly going to revise some important concepts of machine learning by solving second internal test questions. I am a student of IIPS DAVV, so let's start. We are solving section B, machine learning concepts. First, transforming raw variables into more informative ones is called feature engineering. So, feature engineering is a data science technique which uses several methods on our raw data to transform it into new variables. These variables capture the most important details of our data. Predicting a numeric value such as salary is an example of regression. So in data science, we have two types of problems. One where we are supposed to predict a numerical value. These problems are come under the category of regression, and other where we are supposed to classify some tuples based on certain criteria into a particular class. These problems are called classification problems. A model that fits training data perfectly but fails on new data suffers from overfitting. So overfitting occurs when our model learns too much from the training data such that it also learns about its noise and irrelevant details, which is why it fits perfectly on the training data, but it cannot make correct predictions on the testing data. Dropout and weight penalties are example of regularization methods. So regularization methods are those methods which are used to reduce the overfitting, used to reduce the possibility of overfitting. And dropout and weight penalties are its examples. Training multiple diverse models to improve accuracy is known as ensemble learning. So ensemble learning is a method where we train multiple models based on different parameters to improve accuracy for a single problem. A simple reference model for comparison is called a baseline model. So a baseline model is the one which is used as reference of comparison of different model. It is the simplest model for a problem. Independent unchanging data samples are described as independently and identically distributed data, also known as IID. So this data is taken from a distribution where the data values do not normally change and the previous data value does not depend, the next data value does not depend on the previous data value. Parameters tuned before training are called hyperparameters. So hyperparameters are the environmental configuration variables which are set before training the model. These parameters, the way these parameters are hyperparameters are tuned, decides the how the model is going to learn, the model's architecture, and how it will affect the learning process. Example of hyperparameters could be number of layers or the batch size. Comparing two versions statistically to see which one performs better is A/B testing. Normalization typically rescales numeric features to range -1 to 1. So normalization is used when our data ranges from very small to very large values and there is large fluctuations among data. So to avoid the domination of large values on the learning process, we use normalizations to scale the data from in range -1 to +1. The difference between training and test performance measures model generalization. So generalization is an ability of a model to make correct predictions on an unseen data, basically data which was not used in training, used as a training data set. So the smaller the difference between the training and testing performance, the better the generalization abilities of the model. Bias sampling in data collection can cause selection or sampling bias. So selection or sampling bias takes place when we prefer to take only a particular group of data into our sample from the population while we do not take other kind of data, hence there is less variation and there comes selection or sampling bias. A model trained once and not updated further is a static model, while opposite to that, a model that continuously retrains on new data is a dynamic model. The loss function measuring divergence between predicted and true probabilities is cross entropy. So cross entropy basically quantifies the difference between two probability distributions. It is used as loss function that measures the divergence between the predicted and true probability distributions. Hence, these are the some concepts which we have successfully revised here and solved these questions. I hope you learned something from this video. If yes, then please consider liking this video and subscribing to my channel. I would like to express my heartfelt gratitude to Dr. Shaligram Prajapat for guiding me throughout the semester. I hope you like the video. Thank you.